For us to prove this trig identity, there are two routes we could follow here. You could either start expanding using addition formulae for sine and cos. It's going to be quite involved. Or you might be able to recognize a double angle formula. And this is precisely why you should learn your double angle formulae. Sine 2a is 2 sine a cos a. Cos 2a is cos squared a minus sine squared a. And there's another two versions of that. You could also write it as 2 cos squared a minus 1 or 1 minus 2 sine squared a. We don't need those here, but have these at your fingertips if you can. Because in this question, the left-hand side looks a lot like this. And it must be then that minus cos 2a is sine squared a minus cos squared a. Right, and now we can see that the left-hand side is actually, it's that, just with a replaced by theta plus 45. It's going to be minus cos of 2 theta plus 45. So we managed to use that to go, like, no expansions needed, well, yet, just got it in terms of something that's a little bit like the double angle formula for cos, but it's going to be minus cos 2 theta plus 90. Okay, we've got to show that this is sine 2 theta, and for this I'm now going to expand using the addition formula for cos. So I'll get minus, then cos 2 theta cos 90 minus sine 2 theta sine 90. Cos 90 is actually 0, so that will cancel. Sine 90 is 1, so we will get minus sine 2 theta, and hence sine 2 theta. It's a good approach, and that is the one the mark scheme was looking for. Now, a longer approach, but valid, is as follows. It's going to be to expand straight away from the beginning using addition formulae. So we could write down that sine theta plus 45 is sine theta cos 45 plus cos theta sine 45. And cos and sine 45 are actually 1 over root 2, so we get 1 over root 2 sine theta plus cos theta. And therefore, sine squared theta plus 45 is 1 over 2 sine theta plus cos theta all squared. And then we'll do similar for cos. If you're happier with this because you think, you just wouldn't have ever got the original one that I did, then it's fine. Now we get cos theta cos 45 minus sine theta sine 45, which is going to give 1 over root 2 cos theta minus sine theta. And if I'm squaring it, I'm just going to do this quickly now. I could write it like that. Okay, just save myself a line. So now I can say the left-hand side is therefore going to equal a half. And then in brackets, it will be sine theta plus cos theta squared minus cos theta minus sine theta squared. Okay, remember this is a double bracket, so I'm going to get sine squared theta plus cos squared theta plus 2 sine theta cos theta. Then I'll be minusing cos squared theta plus sine squared theta minus 2 sine theta cos theta. The sine squared and that minus sine squared are going to cancel. The same with this and this. And I'm actually just going to get a half of 4 sine theta cos theta. We're nearly there. This is 2 sine theta cos theta, and that is sine 2 theta. So it It wasn't too much more, to be fair. You know, just a bit more expanding brackets and everything. But you didn't have to kind of use this result up here. But anyway, two different methods. Well done.